Hello, this is a short video presentation on greatest common factor. If you know how to find the greatest common factor, with or without variables, you may skip this video. This is a review for those of you that need it. But you need to know how to do it. All right, if you're watching this video, I would pause the video and copy down these three definitions. All right, first of all, factor. Factor. What is a factor? It's a number that divides evenly into another number. For instance, if you look at the number 24, 6 is a factor. 6 is a factor. Why? Because 24 divided by 6 equals 4. It goes in evenly. All right? Common factor. If I have the numbers 48 and 60, 48 and 60, 4 is a common factor. Is a common factor. Why? Because 48 divided by 4 is 12, goes in evenly. 60 divided by 4 is 15, it goes in evenly. 4 goes in evenly to 48, and 4 goes in evenly to 60. So it's common. It works for both of them. Common means that it works for both numbers. What we're concerned about today is finding the greatest common factor. So I want to look at a couple of quick examples, starting with 48 and 60. 48 and 60. I want to find the GCF, greatest common factor. GCF. One way that I do it is by looking for prime numbers. Just start with prime numbers. What's the smallest prime that goes into 48? 2. How many times? 24. And I'm just going to divide by 2 till I can't divide by 2. 12, 2 goes into 12, 6, 2 goes into 6, 3, and I'm done because 3 is prime. I'm going to do it here. I get 30, 2 goes into 30, 15, and then 3 and 5. I then look for the numbers that are common. I have 2 2's, and I have 2 2's over here. I don't circle this third one because I don't have a third one over here. I have a 3 on both sides. I circle that. My greatest common factor then equals 2 times 2 times 3, or 12. Now, some people don't like using my little box method there, and they learned going like this: 2 and 24, 2 and 12, 2 and 6, 2 and 3. And then the 60, 2 and 30, 2 and 15, and 3 and 5. We're just repeating the same thing. We have 2 2's on both sides. We have a 3 on both sides. We're going to get 12. I don't care how you do it. It does not matter. Now, I use prime numbers sometimes. For instance, if I'm looking at 96 and 72, 96 and 72, instead of saying 2 goes into 96, I might say, I know that 6 goes in here 16 times, and I know that 6 goes in here 6 times and lost 12. Whew. So as long as this is the same number, doesn't have to be prime. You know, you see a number that works, use it. 16 times 6 is 96. 6 times 12 is 72. What goes into 16 and 12? 4 goes into both of them. Has to work for both of them. And again, it's not prime. I get 4 and I get 3. There's nothing common between these two. My greatest common factor is 6 times 4, or 24. Lastly, we're going to look at a simple case, but with 3 numbers: 6x to the third, 9x squared, and 12x. You need to look at the x's and the numbers separately. So when I look at the numbers, 6 is 2 and 3, 9 is 3 and 3, 12 is 3 and 4, 2 and 2. I have a 3 common, a 3 common, and a 3 common. I have no 2's here, so my greatest common factor is 3. When I look at my x's, I have 3 x's, I have 2 x's, I have 1 x. The only thing I can possibly circle is 1x. That's all that's in common. So my greatest common factor is 3x. There's no need to write this down. You don't need to write that down. Imagine you have 1x, 2x's, and 3x's. If you were circling them, the maximum you have here is 1. You can't circle more than 1. I have 2 here, I have 3 here. My greatest common factor is going to be 3x. All right, if you needed to see this, I hope it helps explain what a greatest common factor is and how to find it. I don't care how you find it. 90% of the time you can do it in your head. 95% of the time. There's no need to show work, but you need to be able to find it. All right, hope this helps and have a great day.